over this? Yes, type 2 error should be really easy, especially based off the problem we just did. Their typed answer, a type 2 error occurs when the alternative hypothesis is true, but the null hypothesis is not rejected. In this situation, a type 2 error would happen if the mean systolic blood pressure of the population of employees actually is greater than 122, but the null hypothesis is that it is not rejected. That's confusing. I don't like the way they worded that one. In other words, a type 2 error. Okay. Yeah, I don't like. Maybe the way they worded the end. This is a terrible answer key for them. A type 2 error would happen if the mean systolic blood pressure of population actually is higher than the national average, but the test does not conclude that it is higher. So the data showed that it is not higher, but it actually is. I don't know why they wrote all that stuff ahead of that, except to be confusing. All right, so part B, they give you more than they needed to give you, and I think that's the first part where it's confusing. So if I just start writing stuff down, this is my mu, or now we know we call it like mu naught. That should be kind of a hint to you. So mu of x bar equals what? Which equals. So this is the part that they are making confusing for no reason. What is this equation? So what is sigma? What is square root of n? And then so I end up getting what? And so it gives me this value, but then it also gives me this value, and I think that is confusing. That is not testing what you actually know. Like, I think their wording there is confusing for a way that doesn't test what you actually know about the problem. So that's the first thing I think is confusing. Now, this last part is very close to what we did at the beginning of class today. So if I am doing a test statistic, what is my equation? And I could write that, or I could write but either way, it's going to end up being 1.5 down here, whether I write it like this or write it like this. So I don't know my x bar. That's what I'm trying to solve for. What is my mu? We know that down here is either going to be 15 over square root 100 or 1.5, which is the same thing. So where do I find what to set this equal to? So this is telling me that it should look like this. If this is 0.05, I have to find my critical value. My critical value is either Z or T, but because it gives me, then I know I'm using Z. So this actually ends up being the same kind of problem we just did. If it is Z, and this top area over here is 0.05, then what is my cutoff line? So anything what from this value would reject? Greater than. So I am seeing what x value would give me that, and then any x bar value above that would reject it. And then so there it's algebra, and you end up getting that you need your x bar, and this really would be, it says anything greater than that rejects it. And you end up getting what? And what are my units in MHD? Right. So these are the values from here over that would give you ones that reject the null, which means there is sufficient evidence to reject it. Yeah.
just the equation above should be less than, it should be greater than, should be higher.
Oh, yes, because the X bar has to be greater than, yes, thank you. That's why I usually write that and then go backwards from there. That's right. Questions on this problem? Showing you a little bit more, but not all of it, of the rest of this problem. So we just did A and B. Now here, the mean systolic blood pressure of all employees at the corporation is 125, not the hypothesized value. So using the actual mean and the results from part B, determine the probability that the null will be rejected. Don't worry about that right now. So here, if this actually is the mean, and we're using this, the probability that our null hypothesis will be rejected, given what? So the actual, let me go back here. This whole section right here is telling us what?
That, the null hypothesis is actually.
That the null hypothesis is actually false. That's what that whole section is telling us. And I'm telling you this is a difficult problem. Here, it asks us the probability that the null hypothesis will be rejected. So it's saying here, right? And all part D asks, X out of it, dang it, was what is the term for the answer in part C? Power. That is literally the answer to that problem. Part 6, number 6 is worth 25% of your grade. If you could think that, and I have a student that during this year that we had it, that had that answer right, and I think that was the difference in the fact that she passed and didn't pass. She wrote the word power and she passed. Does that mean you had to get this right to pass? No, but she was a borderline student and she got that answer in a problem that counts a lot. So don't look at number 6 as something that is scary. Look at number 6 as it is a potential to help you go over that line. Does that make sense? So most people are going to look at number 6 and panic. Most people, as in not you guys, like other people that take it. So you need to look at it from the perspective of what can I find out of here to help me out. And I just kind of want to like slowly start introducing you to what AP exams will look like.